Okay, let's start. Hello everyone and hello from Malaysia. Welcome to the 10th program of the Biosafety and Biosecurity Month October 2020, a month to raise biosafety and biosecurity awareness. And thank you very much for your participation today. You have joined our webinar on biosafety and biosecurity in a nutshell, and we'll begin our program shortly. I would like to kick off today's program by reminding you some of the housekeeping items seen on the screen. First of all, please turn off your microphone during the section and only unmute when you are required to speak. Please turn on your camera so that we can see each other. If you have any questions or comments, please feel free to message us on the chat box. We will try our best to address your concerns. The chat box is also there for you all to introduce yourself. Please give us your name and your organization. Last but not least, no phone call or disruption during the section. Note that this section will be recorded and live on YouTube. The recording will be saved on our YouTube channel right after the sections. An evaluation survey will appear at the end of our section. Please spend some of the time to provide your feedback, as it will be really meaningful for us to improve our next section. Thank you very much for your attention, and once again, welcome all to the 10th section of the Biosafety and Biosecurity webinar series organized by AIMST Institutional Biosafety Committee as a part of October 2020 Biosafety and Biosecurity Month at AIMST University. My name is Corinne Singh. I'm proud to tell you that I'm a BSc Biotechnology degree student at AIMST University. It is a great honor for me to serve as the MC for this Biosafety and Biosecurity webinar series. If anyone has any issue with audio or video, please use the chat box. We will do our best to help you. To start the section, I invite IBC Chairman, Senior Associate Professor Dr. Subhash to say a few words and introduce the moderator of today's webinar. Dr. Subhash, floor is yours.
Thank you. Thank you very much, Yin Singh. A very good morning to all of you. We have registered participants from different time zones. So I think I can say good morning, good afternoon, and good evening to all of you. So on behalf of AIMST University and on behalf of Institutional Biosafety Committee of AIMST University, I welcome you all. I want to thank all of you for taking time to join us for this webinar. The ultimate purpose of this Biosafety and Biosecurity Month is to raise the awareness about biosafety and biosecurity among our students, staff, stakeholders, as well as associates of the AIMST University. However, since we are working in new normal, now conducting meetings online or webinars, it's not something different or new. Now whole world is practicing this one. So we have taken advantage of that one, and we have opened all the webinars to everybody. And as a result of that one, we have a wonderful response. We have registered participants from number of countries. I will tell you details in short time. So I firmly believe that all these webinars which we have organized, as well as poster presentation competition, definitely will help all the participants to learn different elements of biosafety and biosecurity. And as a result, it will help to raise the awareness among them about biosafety and biosecurity. So to promote the biosafety and biosecurity, because we are almost at the end of the Biosafety and Biosecurity Month, because now today is 28. So we had organized 12 webinars, and poster presentation competition is pending, which is on coming Friday. I hope all of you will join. So altogether, we have more than 320 participants, and all these participants are from 12 different countries. We have participants from Algeria, Australia, India, Indonesia, Japan, Libya, Malaysia, Nepal, Nigeria, Philippines, United States of America, and Vietnam. So I'm delighted to see all these registered participants in today's session. Maybe some of them will join a little bit later. So I want to take this opportunity to thank senior management of AIMST University for their full support in implementing this Biosafety and Biosecurity Month at AIMST University, because full support of the management is very essential if you want to implement something. So I'm grateful to AIMST management for their full support for this Biosafety and Biosecurity Month activities. I also want to record my thanks to all the members of Institutional Biosafety Committee of AIMST University, because they are very helpful and cooperative in making sure that everything is going smoothly during the Biosafety and Biosecurity Month. And today we have a very experienced and wonderful speaker, Joel William. So I want to thank our today's speaker for accepting our invitation and becoming part of our Biosafety and Biosecurity Month. I also want to thank, actually, it's a special thanks to our today's moderator. Our today's moderator is Miss Iris Sruddhi. She is from United States of America. She's extremely busy. So, but she accepted our invitation, and she was so kind to serve as a moderator of this webinar. So I want to thank especially Ms. Iris for accepting the invitation and becoming a part of our Biosafety and Biosecurity Month. I just want to highlight a few things about Ms. Iris. Iris is a senior member of the technical staff in the Global Chemical and Biological Security Department at Sandia National Laboratories in New Mexico, United States of America. Currently, she's serving as a country lead for Vietnam, Thailand, and Algeria, and manages and implements laboratory virus management programs funded by the United States Department of Defense and Department of State. Technically, she leads a virus management curriculum development activities engaging higher educational institutions globally to successfully establish sustainable virus management education programs, which eventually will prepare the future workforce to prevent or to effectively respond to outbreaks that can cross human, animal, and environmental health sector, or in other words, we can say for the One Health security. Prior to working at the, her current position at Sandia National Laboratories, Iris worked as a project manager for Iraq during difficult time, and for the Iraq scientist engagement program at CRDF Global Supporting Non-Proliferation Programs. And it was focused on biosafety and biosecurity in line with the focus of biosafety and biosecurity of the Department of State. In addition to this, she have a wonderful experience of over 10 years, where she worked with various NGOs as an international development and emergency response and humanitarian assistance program manager, where she designed and implemented USAID, OFDA, and UNICEF and other donor-funded development programs. She has provided leadership and oversight to programs in Europe and in the other parts of the, various parts of the Middle East and the Caribbean region, as well as Caucasus, with various range of technical focuses from, for example, rural community development, youth education and development, infrastructure development, and emergency response and humanitarian assistance. Country-wise, she have a wonderful experience. I'm proud we have a wonderful moderator today. Her country experience includes Iraq, Haiti. She was working in Kosovo, as well as currently she's in charge of the Vietnam. And as far as education-wise, Iris holds a master's degree in international development. That's why she have a wonderful experience of working on various international projects and programs. So her international, master's in international development is from the American University in Washington, DC, United States of America. So Iris, I know you are extremely busy. So thank you very much for accepting our invitation and becoming part of our Biosafety and Biosecurity Month. I highly appreciate it. And on behalf of AIMST University and on behalf of Institutional Biosafety Committee of AIMST University, I thank you for accepting the invitation. Last one but not least, I want to thank our biotechnology students. I want to admit that it would have become very difficult without help of biotechnology students to implement this Biosafety and Biosecurity Month at AIMST University, because behind the curtain they are the players. Those are doing most of things to make sure that all these sessions will go smoothly and nothing will go wrong during the webinar session. So I'm very proud of biotechnology students, and especially I want to record my thanks to all biotechnology students. Those are involved in implementing Biosafety and Biosecurity Month at AIMST University. Really, they have done a wonderful job. We are almost at the end of month, and so far we don't have any problem. So it reflects how biotechnology students are working or how serious they are. So once again, thank you, all of you. And without further ado, I request MC Insing, please lead the way.
Thank you, Dr. Subhash, for the welcoming remark. Now, I request moderator of the webinar, Ms. Iris Shoji, to introduce the speaker and start the section. Ms. Iris, please.
Well, thank you so much, Dr. Subhash. It's an honor to be here tonight, my time. I should just say Selamat Pagi to Malaysians. And it's a delight to be part of this Biosafety and Biosecurity Month. Also, I'm very honored to really present or introduce Mr. Joel William. Mr. Joel has a very, very strong background, and he's an enthusiastic professional who has spent close to 14 years in engineering and construction sector, executing projects of multitude, size, and complexity for high-tech industries in Singapore, Malaysia, and Indonesia. Started as a project engineer with Excite Singapore, previously known as M&W Group. He served as a director and general manager for Excite Malaysia before establishing the Mehdini Group with a base in Malaysia. He has a strong focus on life science and chemical division, enabling various projects in the following sectors: medical devices, pharmaceutical biotech, chemical and research and development facilities, including biosafety labs up to BSL-4. As a project lead, he has completed projects that have met very stringent international standards, from WHO to CDC to CGPM, etc. He was involved in leading design for biocontainment and research labs in Singapore, India, and Indonesia. Please, let's just welcome Mr. Joel William. Thank you for being our main speaker for tonight. Mr. Joel.
Thank you, Iris. Thank you, Dr. Subhash. All of y'all seem to have very nice background. It's about time for me to get some nice Zoom background as well. Thank you for the kind introduction. So let me open my presentation and share my screen, and let me know if you can see my screen. Can you see my screen?
Yes, we can see. Perfect. Go ahead.
Okay. Let me see if it works. Okay, so just to add on Ms. Iris' introduction, I work for an engineering and construction firm and served quite a number of countries and different types of projects. And the reason why I volunteered and was really interested in this this speaking topic was because of my previous involvement in designing and building biosafety labs. And a lot of my talk today is going to revolve around that experience in presenting the different types of biosafety labs, touching a bit on biosecurity as well. So one of my key highlights during my career is to hand over biosafety level 3, level 4, animal biosafety level 3, level 4 facility for Ministry of Agriculture in Indonesia. That was completed a couple of years ago. And besides that, I've done some projects on medical devices, pharmaceutical plants. So I understand that my presentation is the last presentation, and my topic is, biosafety, biosecurity in a nutshell. So today's talk will be very basic and should be very short as well. And the reason for that is that I hope to have a lot more interactive sessions with the participants. And if you have a lot of questions, then we can dive down deeper into areas. If the question is something that I can answer, for sure I'll do that. Otherwise, I'm going to pass the ball to Ms. Iris, who for sure has a lot more experience than myself. So just to answer the fundamental why biosafety and biosecurity is important to us, and it's amped that the month of October has been chosen for this topic, and I'm really happy that AIMST has taken this upon themselves to basically create the awareness on biosafety and biosecurity, especially in the times like this when there's a pandemic around us. If you look at the news on the left, which actually that was published in the Malaysian newspaper, this is right at the start of the COVID pandemic, and there's a need, there was a topic and discussion on why Malaysia must beef up our biotech expertise, especially in the area of biosafety and biosecurity. And pandemic threats are not new. On the news that you see on the right, it's something that was published more than a year ago, February 2019. And it talks about what happens if there's an accidental or intentional release of a pathogen into the environment, and that can cause a pandemic. And now we are facing a pandemic in a terrible pandemic with COVID. Yeah, so so there's a real need for biosafety and biosecurity, and I hope with this awareness month that AIMST is doing, it has created a lot of awareness, and it will carry on forward, and basically tickle the interest in students to basically take on this topic. There's a lot of scope in biosafety and biosecurity, and to all the biotech graduates out there, I would highly recommend that you look at this topic as a career, and you can make that as a career for yourself as well. Just to add on my credential, I'm actually a biotech graduate, so myself from University of Science Malaysia, and I took a totally different route. Basically, from being a biotech graduate, I went into an engineering construction and did some work on biosafety and biosecurity. So being a biotech grad doesn't stop you from venturing into fields which is not commonly known. I mean, you don't have to limit yourself to work in an R&D site or in a manufacturing plant, but you can also go into various different disciplines. Moving forward, so what is biosafety and what is biosecurity? So just to put things in context, my topic today revolves around biosafety and biosecurity within the R&D sector, or within the laboratory sector, and not taking on the wider biosecurity definition. So biosecurity has got a wider definition. If you simply Google biosecurity, the other big topic on biosecurity is about containing or germs or pathogens within farms, for example. Australia takes biosecurity in a big way, and that's mainly related to prevent or protecting a particular farm or a particular state or particular district from an alien virus or a germ to come in and cause havoc. But for the purpose of this today, we are talking specifically about biosafety and biosecurity related to labs, R&D, and also slightly on manufacturing side. So the pure definition of biosafety in that context is basically the containment principle to prevent unintentional exposure to pathogen or toxic outside of the area where we are working. So it's unintentional. So that's what biosafety covers. And when we talk about biosecurity, it simply says intentional release. So to put this in a layman terms, the goals for biosafety is to protect people from dangerous pathogen, and the goal for biosecurity is to protect the pathogen from dangerous people. Right? So you don't want people to come in, take the pathogen that you're working on, and spreading it out with malicious intent. So that's basically the simplest definition of the biosafety and biosecurity, where the topics that I'm going to touch today. And then within that, there's a biorisk element. So when you talk about biorisk, it's actually a combination of biosafety and biosecurity. So in terms of when we design a lab or when we build a lab, we need to look at the biorisk perspective, which then has got the component of biosafety and biosecurity put in together to come up with a lab which addresses both concerns. If you have any questions, I think you should be able to raise a hand or ask or step in. I should be able to address that immediately. So how does all that being guided? So there are many guidelines. The oldest, or the Bible for this topic, is the BMBL, or what's the Biosafety in Microbiological and Biomedical Laboratories, the second line here. Basically, BMBL was established in 1984 and has through many revisions. So the latest revision that we have now is revision 5. They were supposed to release revision 6 this year, might be delayed with all this COVID situation. But as for the guiding principles on how some of these labs should be designed and what are the guidelines, typically we fall into this various guidances. So typically when a lab is being designed or built, or when you want to fall back into a particular authority, you would decide from day one which guideline you want to follow. So there are Canadian guidelines, there are American guidelines, there are also Australian, New Zealand guidelines. So typically before the project is started, they will say, okay, I want my lab to comply to the American guidelines. And then basically then it will be based on the BMBL requirements. Some might say, I want it to comply to the WHO guidelines, and then there are different sets of requirement. And then basically, then you need to appoint a certifier who is familiar with the particular guideline to help you guide from day one on setting up the project, and then making sure that the facility will be certified to that particular guideline at the completion. So typically a lab like this will need an annual certification, and then this basically the certifier would come in, do the necessary checks, and make sure that the lab is still functioning for the intended purposes and nothing is failing within the lab. If they see that something that has failed, they'll basically will not give the certification, and the lab has to stop operation. So the guidelines are very important and has to be defined at a very early stage. Typically, what is going to be your guiding principles throughout the whole project. It could also be a combination of both. If you want a stringent lab, I say I want it to comply to American, Canadian, WHO, and New Zealand standards. That becomes slightly a bit more stringent requirement, but it also becomes more costly to build and to operate. So touching on the biosafety component of that, so there are 4 different categories for biosafety, and these categories are basically determined on the type of pathogen that you're dealing with. If a lab is being built for biosafety level 3, they cannot work on a pathogen that falls under the biosafety level 4, for example, right? How do we then risk these pathogens? These pathogens are basically evaluated and will be globally agreed upon on what level they stand based on their pathogenicity, the route of transmission, how much of fatality it can cause, etc. So here we have the different levels and the different agents. If you look at basically a biosafety level 1, so this is a very standard, very simple lab where the agent is not known to cause disease. So basically you could be isolating something from the environment, and that agent is probably not known to cause any disease, that you can actually work on a biosafety level 1. And then it goes, the criteria goes further up, BSL2, BSL3. BSL3 is a lot more complex than BSL2. BSL2 you can find in a lot of research centers. In Malaysia, there are very limited BSL3 or recognized BSL3 labs. This is where you actually work with slightly more indigenous or exotic agents. And then BSL level 4 is basically really for dangerous and exotic agents that cause life-threatening disease and can be readily transmitted. So one might be wondering, COVID or SARS-CoV-2 basically falls under which category? Is it a BSL3 or is it a BSL4? That debate has taken up in the last couple of months, and I'm not sure if you can, if it's on an open lecture, I'll ask people to answer. I'm not sure if there's way for you all to give your comments. Some might think it's BSL3, some might think it's BSL4. Actually, it falls under BSL3. The reason being, although it's dangerous, it's exotic, it can be easily transmitted, the fatality rate, the mortality rate is actually very low. So that's the reason why a lot of agencies are categorizing this COVID as BSL3 agent. That being said, it also makes it easier for people to work with this particular agent. So you can work in a BSL3 lab if you want to propagate and study more about the virus, or if you're doing isolation, for example, from a COVID patient, you can actually work on a BSL 2 level lab. If you have taken a sample and you want to test whether it's positive or negative, this can be done within a BSL 2 level. So BSL 4, it's really reserved for agents like Ebola or Marburg, where those kind of release, it's really disastrous for the human population and can and really there's no treatment for it. So BSL 4 types lab, it's really limited also globally. Not many people have chance to work in such lab or even to design and build such labs. So these are basically a snapshot of the different biosafety levels and how the labs gets complex to handle such agents going forward during your R&D. Where can you find such labs? BSL1, as I mentioned, it's very simple lab, open bench working areas. BSL level 2 and level 3, besides the diagnostic or R&D centers or universities and Institute of Medical Research, they can also be found in manufacturing plants. So I think this is really key component here, especially for biotech graduates who wants to go out and work in a manufacturing plant, for example. So I've worked in manufacturing plants in Singapore that actually has got a BSL-3 lab. And that's mainly because the agent that they're using to manufacture the particular drugs or the vaccine falls under the category of BSL-3. So meaning that when you have such agents in your factory, in your manufacturing plant, you should be able to contain them, treat them, and discard them using the BSL-3 principles. So not only such labs are present in R&D sites, but also they can be present in manufacturing sites. So as the containment level goes up, the lab practices also goes up, the procedures, the SOPs gets even stringent, and the equipment that these labs have also gets stringent across the board. So the next part of the presentation is basically looking into the various types of labs and how they are built and some of the safety components that these labs hold. But before we go into the labs itself, one of the biggest, the heart of the facility, the heart of such biosafety labs is the biosafety cabinets. So being biotech graduates, a lot of y'all I see that currently studying in AIMST, you would be familiar with biosafety cabinets. And again, there are many types of biosafety cabinets and serving different purposes. So typically there are class 1, class 2, and class 3. So don't confuse this with the class 1 or class 2 of the biosafety lab. They're slightly different. So this is biosafety cabinets are related. This classification is only related the way the biosafety cabinets are built and the purposes of how it's being used, and where it fits into the various lab component. Going a bit more into detail, the class 2 is something that's really commonly used in biosafety labs, and within the class 2 there's a variation. There's type A1, A2, B1, and B2. So this is quite important for users to know and to differentiate the various biosafety cabinets, because not all cabinets work using the same principle. The principle how it's designed, the principle how it should be used, and how it should be installed are different for the various category for the biosafety cabinets. If you look at the picture at the bottom here, that basically shows how these cabinets are built, installed. And also, for example, if you look at the exhaust from the biosafety cabinets, so A1 and A2, only 30% of the air that goes out of the cabinet is exhausted out. The rest 70% gets recirculated within the cabinet, doesn't go into the room. But if you look at the most stringent types of class 2, B2 cabinet, 100% of the air is exhausted out. It goes through HEPA filters and sometimes double HEPA filters before it's safely discharged to the environment. And a lot of these cabinets are made to protect both the users as well as to protect the product, right? So this is not as similar to a laminar hood cabinet. A laminar hood cabinet only helps to protect the product, and the principles are different, right? So the positive and negative pressure plays a part. Whereas the biosafety cabinets are always to protect both the users when you're using those cabinets and the product that you're basically installing or operating inside the cabinets. One other important thing is the chassis opening, right? So how much should it be open? That also plays a big criteria. So what I would highly recommend, students, researchers, is when you look at a cabinet, don't assume that this is a particular type. Please check the manuals and understand the operating procedures of such cabinets to make sure that these cabinets are being used properly. Because if they're not used properly, it doesn't serve its purpose, and you might cause contamination, or worse still, cause exposure to yourself. Now, coming out, looking at a bigger picture, looking at the building principles. So when we design such labs, we look into the various containment level, right? So in this case, you have the primary containment barrier. When I say primary containment barrier, this is basically which comes into direct contact with a particular agent. Right? So if you're working with a particular virus or a bacteria, the primary barrier is the one that comes into contact with this agent, and the barrier is actually designed to be able to be in touch with this agent. So here we are talking about the gloves that you wear, the gown, the biosafety cabinets themselves, or the flask, the glasswares that you use. So all this are basically a primary barrier. So they're actually meant to be, see there's some chat. Okay. They actually be meant to be in contact with the agent. And then you have the secondary barrier. Now, the secondary barrier is your environment, your room, the air handling unit, the filtration deck, the floors, the doors. These are not actually meant to be in contact with the agent, but if the primary barrier fails, the secondary barrier should be able to contain it. So, for example, in a lab, if there's a hole or the drain is not properly secured, if the drain leaks to the lab below, and if the primary barrier fails, the secondary barrier will, if there's a leak, it fails, and that it causes exposure to the next level, right? So this barriers gets more stringent based on the type of lab and based on the type of agent that we are, or that you will be working with. The tertiary barrier is mainly to protect outside. So this is the last barrier. If this barrier fails, then basically the agent is out in the environment, right? So so every principle, every component of each barrier will be designed, looked into, and made sure that it serves its intended purposes when we are designing it and when we are building such labs. So coming back into the different criteria, so what we look at, the location of the laboratory is important. We cannot, have a laboratory that is built in a greenfield area somewhere out in the woods. Of course, if you do that, then you need to have all that secondary and tertiary barriers properly in place. Ideally, most of these labs are built within an existing institute or infrastructure. The surfaces, for example, when we build these labs, the surfaces, the wall has to be super smooth. And the way they test this, the inspector will come in with a glove, and he will, basically rub the wall with his hand. If there are small particles in the wall that can cause tear to the glove, basically then the wall has failed. It doesn't serve its purpose. It's not smooth. So yeah, all the surfaces should be very smooth. There should be covings on the floor, covings on the ceiling. There shouldn't be anywhere where it gets difficult to clean. When they do disinfection, all the areas should be able to, the disinfectant should be able to penetrate all the areas and kill if there's a spill, or when you do your annual or regular decontamination processes. HVAC, basically the ventilation system, actually it's the key for all labs, because this is what basically provides the fresh air for people to work comfortably, provides the right temperature, humidity within the lab. But above all, this takes away the potentially contaminated air, treat the air before the air is released to the environment. So if the HVAC system fails, the lab should be immediately shut down. There's no such thing as, the aircon is, if you're working in a lab, BSL, even a BSL2 lab, if the aircon system has failed, the extraction fan is not running, you'll be highly recommended to stop all your work, secure the tables or your workbenches, and leave the lab immediately. because the moment the HVAC system is not running, your lab loses the negative pressure. So the air can potentially leave out of the lab into the outdoor areas. So the HVAC system is really a key component and becomes very complex as the complexity of the lab goes. Directional airflow and cascade negative pressure. So basically, this is again where the HVAC system works. And all these labs are always under negative pressure. When I say cascading, meaning the corridor will have slightly lower, slightly higher pressure than the rooms. So basically, the air will move from the corridor into the room, and then your biosafety cabinets will have the highest suction, highest negative pressure. So the air basically moves from outside of the building into the corridor, into the various rooms, and gets extracted out through the exhaust. So that's why the HVAC system, again, it's very important. Selection of the furnitures and equipment. You don't want to have a wooden bench in your lab. It becomes very difficult to sterilize it, so on and so forth. Autoclaves, even your incoming water, for example, if you have a water or a compressed or a vacuum system or a compressed air coming into the lab, and all those becomes possible areas of leakages in the future, right? So all that needs to be protected. And of course, the electrical system. If you look at the picture right at the bottom on the right, you'll see the conduits are all airtight and sealed. So any cables that's running out and in of the lab must be all properly sealed. So basically, there's no air movement through this open conduits. So these are some of the criteria that is looked into when the labs are being built. We'll briefly run through the different types of labs. So PSL1, I mentioned, it's a very simple lab. If you look at the picture, there's no corridors, there's no change rooms or empty room. You can straight go in, do some work. Of course, you have other stuff like your fridges and your biosafety cabinets. There's no particular gowning processes. Of course, you need to wear gloves when you're handling with different agents, but it's a very simple procedural lab, right? So you can have them in schools. A lot of all universities have them, and also some of the manufacturing plants. Biosafety level 2, if this has to be built, then basically as I mentioned earlier, the guidelines will start to apply. So you need to have a look at the guidelines. You need to look at the agents that you're working on. And then this lab gets a bit complex. So you will have a change area before you enter your labs. And then you need to have your different types of HVAC systems. All work needs to be done within the biosafety cabinets. And then these are some of the sample agents that you can actually work on biosafety level 2. As I mentioned earlier, if you're doing COVID testing, it can be done on a level 2 lab, as long as you're not propagating the virus. It has to be done within a biosafety cabinet. Now, this is where the complexity really starts, BSL level 3, and that's why you don't really see a lot of BSL level 3 labs, in Malaysia as well as globally. The types of agents that you work on here is like anthrax, SARS, mad cow disease, and what increases the complexity of BSL 3 is the BSL 3 has got a variation. Right? It can be BSL 3 plus. So depending on the agent, again, if you don't have a BSL level 4, you could work on a BSL level 3 plus if it's allowed by the risk profile. And then there's BSL 3 ag, is where this is basically when it says agriculture, is where you actually keep larger animals in the lab. For example, if you have a cow, for example, you can actually have a very big lab that you can actually put in a cow or different animals like chickens or poultry, and that becomes a BSL 3 AG, where you're handling bigger animals in this labs. A bit more on the BSL level 3. So BSL level 3 will be an add-on on BSL level 2. So you need to have everything that you have in BSL level 2, plus you need to have airtight construction. The lab must work under negative pressure. So there must be at least minus 15 Pascal between each entrance point that you see here. You need to have autoclave. Nothing leaves the lab before the particular thing is sterilized or in a sealed container that you can take it off site for further decontamination. right? So those are some of the critical areas in BSL level 3. All air that goes out of BSL level 3 must be decontaminated. So it must go through HEPA filters, and there are always redundant systems to ensure if one HEPA filter fails, there's a second redundant HEPA filter in that. There'll always be airlocks, and you typically need to work in pairs. In a lab like BSL level 3, you're not supposed to work alone. You need to always have a pair working with you, because if there's if there's a spill of someone is having a heart attack or something like that, you need to have the second person in to basically manage that risk. So you cannot work alone, for example, in a BSL level 3. And generally, types of labs like this will also generate a lot of waste. It could be liquid waste, solid waste, and there are ways to treat that, which I will address slightly a bit later in this presentation. The other key criteria, it's when you leave this lab, a lot of the risk protocol will request that you have a shower. So basically, you have a shower room, and you shower, you change your clothes, you leave all the clothes that you wore inside the lab, and you get a fresh clothes through an airlock to get your particular PPEs. So, and to work in such labs, you need to really go through a lot of training. Without training, one cannot enter BSL level 3. So the trainings are very stringent, and only upon completing such training, you're actually allowed to work in a BSL 3 level lab. Next, we look at basically the biosafety level 4 types of lab. This kind of labs are very, very rare. Malaysia doesn't have a BSL level 4 lab. China lately has been having a lot of labs. They've been building such labs on a regular basis. And actually, one of the articles that was published, what you see on the right, this is actually an article that was published back in 2017, which is actually talking about the Wuhan lab. So a lot of them had, during the COVID, a lot of rumors were there that this particular COVID virus was actually being released out of the Wuhan lab, but there's no proof going into that direction. The scientists still believe that this is coming out from the animal and not labs in the lab that actually released this particular virus. But this kind of labs are important because this is where you actually can handle agents which, as you can see on the left, Ebola, Marburg, and all these exotic agents that can cause big devastation if they are out in the environment. There are two types of biosafety level 4 labs. There's a type of lab that is called the cabinet lab. So this is easy to be done. So if you can see on the picture here, what we call the cabinet, or actually a glove box. This is what we call the class 3 biosafety cabinet. So basically, the lab environment is shrunk into that glove box, and this glove box has to be set up within a BSL 3 environment, right? So if you have this cabinet or the glove box, and then you have it within a BSL 3 plus environment, then that you can actually work on a BSL 4 agent inside the glove box, right? So that's one possibility of having to work with BSL 4 agent in a glove box within a BSL 3 plus environment. The most expensive one is the suited ones, where if you were to work in a BSL level 4 lab, you need to have this full suit. It's very common that you see in a lot of movies. I think you see that more in movies than in than R&D or literatures, and how people actually in full suit, they have their own clean air supply. They have to be hooked on to this air supply tubes. It's not an easy environment to work with, and of course the lab gets really difficult, really expensive to build. That's one of the reasons why such labs are not easily present in many countries. So what are the features of a BSL level 4 lab? Basically, it becomes more stringent than the BSL level 3. So you need to have all whatever that you have in BSL plus. you have all this components like the HEPA filter. The air that goes out is filtered twice instead of one, just in case if the first filter fails, second filter is there to capture it. And this labs will be pressure tested. So up to 1500 Pascal, they will pressure test the whole lab and see if there's any leakages. So to avoid any leakages, the walls of this labs are huge, and they are poured concrete instead of brick wall or partition wall. And there are various pressure cascades that basically helps to ensure that the labs stay in negative pressure, and they're really under a lot of negative pressure. One interesting things which happen in many labs, stories which is told to all engineers and builders, when they actually test and commission such labs, sometimes the pressure can be so strong that the walls can crumble in, right? If it's not properly designed, if the HVAC system is not properly designed, either the doors will crumble in, the walls can crumble in. So it gets very difficult to design such labs. And I was fortunate to be involved in one of the design for such lab to be built in India. Unfortunately, they didn't build this lab because of financial reasons, but we actually went ahead to do the full design for a BSL 4 plus, which is including animals, so that can handle chicken, etc. It's a very interesting experience and gets really complex. If you look at the picture on the right, that's how the electrical routing has to be done. It has to be laid down before the concrete is poured, so you're not allowed to make any mistakes during the engineering phase. This is again another picture on how the lab looks like. So actually, if you look at that, there are various components to the lab. There is clean air supply, so you need to have fresh air going into the various suit that people wear. All the water that is being discharged has to go through a decontamination station. So basically a big cooker that actually boils and make sure that all the agents are denatured, killed before it's being released. And then you also have like chemical tank. This is for chemical shower. So in case if there's any exposure, you need to take a chemical shower. So basically while wearing the suit, you go into this particular shower room, and shower yourself with chemicals to basically decontaminate your whole suit before you leave out of that lab. So these are the intricacies of such lab, and it just gets too complex to be simply built. And not only to build, it's expensive to build, but also to operate. It's not cheap either, because of the amount of air that's being treated, and all these things, all the OPEX, operating costs of such labs, also prohibitive. So they don't recommend such labs to be built, because if a lot of the organizations have money to build it, but if they don't have the money to run it, then the lab doesn't serve its purpose anymore. It will fail the certification, annual certification. So that's basically a synopsis of all different types of labs, so BSL1 to BSL4. And then I now quickly touch into the biohazard waste. So what happens to all the material that you bring inside the lab, right? So it has to go out. So it goes out in 3 different ways. One, you have the through the air, or you have, like for example, if you bring a mice that is already infected with a particular agent, you need to remove that. So how do you do that? So the biohazard waste treatment it's really something that needs to be looked into, and all the necessary SOPs needs to be in proper place. So the airborne, as I mentioned earlier, will be treated by the HEPA filters. That's not really an issue. The liquid effluent, so all the liquid that is generated inside the lab has to be properly decontaminated. So this is where you have the EDS system, or the effluent decontamination system, the big cooker tanks. Just to share one experience that we had when we were designing the lab for Singapore, A-Star Singapore, we were designing a BSL3 lab. And this is where it becomes complex. So Singapore has got very stringent fire safety policy, right? So basically all labs must have sprinklers. Now, what happens if there's a fire in the lab and the sprinkler gets discharged? Now, when a sprinkler gets discharged, there'll be a lot of water that comes into the lab. Now, and you can't simply let this water out into the common areas or common discharge. You need to treat this water before the water has to be discharged. So This is again where a lot of the times we need to have a lot of discussion with the various authorities, and it's again, if the authority says no, you must have a sprinkler system, or you look at other mitigation factors, you go for a dry sprinkler system, or you need to have built bund walls around the lab to basically contain this water in case if there's an accidental discharge of sprinkler water, or if there's a fire and the water gets sprinkled down. When we were designing a lab in India, for example, it's a standalone lab, the authority said, don't worry about sprinkler waters. If there's a fire, please allow the lab to be burned down, right? Just allow the whole place to be burned down, and that's one way to basically ensure that everything is basically burned to ground. So discussions with various agencies, you have different input that has to be taken again from the onset. Solid waste gets a bit difficult. So some solid waste can be sterilized in autoclaves. So you have double door autoclaves, open from one side, put in the carcasses or the feces or the bedding, and then you sterilize it, validated sterilization methods. The lab that we're designing for India had particular concern because they were using monkeys for testing. And how do you basically remove them out of the site? So we had to build in animal digesters, especially if they're using agents like prions. Prions are the smallest. They're even smaller than virus, but they cannot be just simply deneutralized using autoclave or chemical decontamination method. They have to be through pyrolysis, through chemical alkaline pyrolysis. So you need to build an animal digester together with the facility to basically throw the carcasses in, put in the necessary acid, heat it up, and then you're allowed to discharge the waste. So that's one of the reasons why when we are designing such labs, we always told you need to limit the amount of material that goes in, because anything that goes in has to come out, and those has to be sterilized. Do not bring your laptop inside the BSL-3 lab. Once it goes in, you can't take it out unless it's properly decontaminated, for example, right? So the best is bring paper and pen. So these are some of the things which has to be thought of while designing or even while using such facilities, because one mistake can cause a lot of havoc. It's a simple sample of a waste treatment system. Basically, all the water goes in, gets boiled, treated, and they need to have redundant system. One system fails, second system has to kick in. So all BSL-4 component has redundancy, 100% redundancy. One fails, second one kicks in. That fails, third one kicks in. So you need to have those systems designed in. Now, I've spoken about biosafety in general. We look at biosecurity issues. Now, biosafety, as I mentioned earlier, is to prevent unintentional release, whereas biosecurity is where we prevent people from taking such organisms for malicious purposes. So for this, again, in labs such as BSL-4 labs, people are screened. Not anyone you can't just simply bring a guest in to visit a BSL-4 lab, right, for example. But that's on SOP. But there's also a lot of physical and engineering things which can be done to prevent such threat. So, for example, when we were designing the BSL-4 lab for India, the authority told us that the way the lab will be challenged, they will send the commandos in to break in through the lab. And so there must be physical securities with boulders and gates, security guards that can actually prevent such intrusion into this kind of labs. So it works out from there all the way into how you protect your agent. Typically, for all this kind of labs, TRA is done, so threat and risk assessment. So we look at the various likelihood of those threat, and then the risk assessment is done, mitigation factors are created, and that would then lead into the various protective measures that should be in place for such labs. before we run out of time, I quickly just skim through the security devices. You have different, I mean, the slides will be given out to you all later. So the various security devices that can be installed, biometric, access credential, and then you have the various CCTVs, door hardwares. Yeah, so that's basically a snapshot of biosecurity. I just want to quickly touch on what's the status of biosafety in Malaysia. So this is in general biosafety. In 2007, we had the Malaysian Parliament passed the Malaysian Biosafety Act, which actually came in force much later. It came in force in 2010. This is mainly to protect our biodiversity. So the act is mainly towards protecting our biodiversity and to prevent from either the biodiversity is being taken out of the country, or if there's an outside threat. This is quite similar to the Biosecurity Act that countries like Singapore has. If we bring in a genetically modified organism, how are the what are the protocols and what are the regulation guidelines to make sure that they are not released into the environment? So our Malaysian Biosafety Act is more related to that, and not as a guiding principle on how biosafety labs, or it doesn't have authority really on the biosafety labs per se. So in Malaysia, the biosafety, if you're building a biosafety lab, it has to comply to international standards, either the American, New Zealand, Australia, or Canadian standards. We don't have a local Malaysian biosafety guidelines that actually that you need to fully comply on. So basically that's it. In a nutshell, we looked at the biosafety and the various biosafety levels, 1 to 4. And then why is biosecurity is important? So in 2001, there was an anthrax attack. Basically, a rogue person has taken samples out of such labs, because the samples, again, are very small. It's easy to be taken out of the labs, and biosecurity is really important to make sure such incidents don't happen. So that's why we have such different guidelines and regulatory processes in place to ensure the risk, the bio risk, is basically managed in all scenarios of such R&D or even on manufacturing sites. So with that, basically I come to the end of my presentation, and feel free to take some questions.
Thank you, Joel. That was an amazing presentation. You just gave a wonderful overview of biosafety and biosecurity perspective from the laboratory design. I think it was a wonderful presentation. We already have a couple of questions for you tonight. But before I jump into that question, you gave some interesting examples on India, that you started a project in India, a BSL+4, and then it was a complex project, as you mentioned. So my question to you would be, how would you advise companies when the budget is an issue, and to put the right biosafety and biosecurity mitigation measures when you're building a laboratory? Do you mind walking us through that process?
Sure.
How do you handle that?
Sure. On just like any other project, like building a manufacturing plant or biosafety lab, it's always you set the budget at a very front end. A lot of the times the budget are just, a lot of them, especially if the owner of the facility, they just pluck the number from the sky. Said, I've got a budget of 300 million ringgit and I want to build X factory. And based on our experience working with various parties, it's always difficult to achieve something within a budget if they don't understand the components of that budget, right? So to answer your question, when a client or when an organization comes to us and says, okay, we want to build X facility, X square meters, X requirements, we will actually use our in-house or known benchmarks, and then based on the benchmarks, gives them a CapEx budget. But CapEx budget alone is not enough, because what's really a deciding factor is also the OpEx budget when it comes to a lab like a BSL4 facility. And as an end users, there's always, I want this, I want to have this, I want to have 2 times the size that I actually need. There's always this incredible requirements that they would like to have, but we always need to bring them down and say, for this requirement, it's going to cost X amount. And, we can do some value engineering, but ideally for a BSL-4 type of a facility, there's not much value engineering that can be done. It has to meet the basic requirements, basic principles, etc., etc. So one of the challenges that we had on that project was because it was a government-driven project. So they had a requirement. They floated the requirement to international parties and say, go and give us a price for this facility. So we cannot come up with a definite price unless you do the design. So we had to do the full design to determine the final actual price. And that's when the organization realized, they didn't have the particular funds or the to carry on with that project. So a lot of projects have failed in that aspect because first internally they set the wrong budget without consulting with the right parties. And then suddenly they have a budget constraint, OPEX constraint, and it's all about underestimating something which they've not done before. So it's not only applicable for such facilities, but also to manufacturing plant, or even when someone's building a house, you have the same problem, right? So I want to build a house for, whatever 1 million ringgit, and realize that he has got a fantastic design which costs 10 million ringgit. So it's bringing back to reality. And
Right. Thank you. Thank you so much. I would like to address the question from Dr. Vips Knudsen. She is from Sandia National Laboratories. And her comment is, to what degree does formal risk assessments and following design rationales play a role in high containment labs in design in Asia? Is it part of design package to the client? And does the A&E company write these types of documents for the users to present to their approving authorities?
So that's a very good question. And I had been in a similar situation. So when we were designing such labs, especially BSL-3 lab, as an A&E organization, we don't have the authority to decide on the risk assessment. So we always dependent on a third-party risk assessor, and we work with various consultants. I've personally worked with many consultants in the past, where their core business is in first developing such risk assessment based on the user's requirement. So they'll always go back to these. So what agents do you want to use in this lab, right? So it always comes back to that. And once the consultants know that, okay, you're going to use X agent for this quantities for this purposes, and then they will develop the risk assessment. And then from then, the risk assessment agent will then give the same input to the A&E firm as well as to the end users, so that you can take it to the next step. Again, the first fundamental question is to what credibility do you want to build such labs? As I mentioned earlier, the guidelines. Right? So do you want that to meet the American guidelines, New Zealand guideline? That also will determine how the risk assessment process is done. So as an A&E firm, we don't have the authority to do that risk assessment. We can support in the risk assessment. So meaning that when the consultant is developing the risk assessment, they'll say, can this be done? Can we have a lab of this size and still put in the autoclave? Those kind of risk assessment, we will, when it comes to facility related components, we'll be able to advise them. But in terms of determining the SOPs, how big the change room should be, what are the protocols, what are the PPE protocols? Do you need to shower in? Do you need to shower out? When do you shower out? So a lot of that will be determined by the consultants, which basically does this risk assessment, or what you call the biosafety consultants. Yeah.
Well, thank you. And I know risk assessment is a very important component of when we build laboratories, risk assessment from biosafety aspect as well as biosecurity. So that gave us an understanding that for you hire a consultant, or the company hires a consultant to do that. So my other question is from Dr. Fong Tse Van. I'm sorry if I'm mispronouncing it. He's stating that unwanted accidents do happen. And so what kind of actions should we take to handle laboratory accidents?
Yeah, so again, this will also form part of that risk assessment. So a simple example is like I'm going to use glasswares in my lab, right? So one of the risks is that this glassware can fall and break and shatter on the floor, right? So then basically that component of that risk will already be addressed in the overall risk assessment, which then will help to develop the SOPs. So what if this happens? So what if there's a spill on the floor? If there's a spill on the floor, do I take a cloth and wipe it, or do I need to pour a bucket of disinfectant on it first before I start clearing it, right? So we can always not we can plan for the accident to happen, but we will know what are the risks that can potentially happen in the lab, and for every risk item there'll be mitigation that will already be planned in that um, uh, in that SOPs. So yes, accidents can happen. What actions to take will actually be dependent on the risk and the SOPs that is predetermined beforehand. If there's an accident which is not in the risk, means that this is something that is really super unlikely to happen, right? So then the best is to follow the standard protocol is to leave the place immediately, right? So to secure what you can secure and leave the place immediately and seal off the place until basically then the right people come in and say, okay, that's the next step to do. You would have seen in movies, right? When something bad happens, they just shut down the shut the door tight. Of course, we want to make sure that the personnel comes out, gets themselves decontaminated, and then we'll treat with that incident based on what's happened on site. So always follow back on SOPs.
Right. Yes. And I have another question. So you mentioned that if we're talking about engineering controls or such as biosafety cabinets, so what are some factors to consider when selecting a biosafety cabinet, and how do you advise companies to determine which biosafety cabinet to use?
Okay, so it comes back to what is the user's requirement, like what's the purpose of that biosafety cabinet, right? So is it to and also what agent are you going to use in that? Work inside the biosafety cabinet, there can be many types of work. Either you're propagating a virus, or you're using the biosafety cabinet to dilute certain things, or you're only denaturating some things, or certain biosafety cabinets. In fact, people do procedures inside the biosafety cabinet. So for example, if you're centrifuging, if you're doing some centrifuge, a lot of the centrifuge must be done inside a biosafety cabinet. So we need to understand what is the purpose, intended purpose of what the user wants to do within a biosafety cabinet. And based on that and the risk assessment and the facilities need. So for example, if a facility does not have an extraction system, then we probably have to go for a biosafety cabinet that treats all the air before it's released back into the lab, if you don't have an extraction system. So that will be a type 2 P2, I think, which also can be exhausted out. So so two things. One is what they need to do within the biosafety cabinet, what kind of agents are they going to use? So that's a risk assessment. And then what's the facility can handle, right? So whether it's going to be within a BSL-3 lab, BSL-2 lab, and then we will decide whether the air should be treated or not, and also how much of the air is treated, right? So the variety of the biosafety cabinet, whether it's 30% air treated, 70% air treated, or 100% of that air treated, which again falls back to that risk assessment and the type of agent that we're using. With biosafety cabinets, also it gets tricky because it needs to be annually certified. So, so the intent and the purpose should be right, and annual certification will pick out if there's any issues with the biosafety cabinets as well. So if you're using the biosafety cabinets wrongly, if there's a compressor doesn't have a filter, for example, or if you're using a lot of gases within the biosafety cabinet, all the gases need to have the right discharge. So those are the factors that plays in determining what's the right biosafety cabinet. But what's also important is that this has to be certified day one before it's used, and also annually it's certified by the competent person before they can be continually be used. Yeah. don't use an expired biosafety cabinet. That's something a lot of places they'll forget. So.
Right, and also sometimes the maintenance of the equipment can affect the budget for whatever mitigation measures you're using. So that brings me to another question. I'll be interested to know. As I said, so far you gave a wonderful example of a perfect laboratory in the perfect world. And we all know that nothing is perfect nowadays. And if I was to say, Mr. William, I would like to build a laboratory in Sierra Leone, West Africa. How would you help me? How would you design a remote laboratory that would handle dangerous pathogens? That if I was to give you this job, so what would you do? How would you design that?
Very interesting, very important question, and I got the right answer for you.
Excellent.
A couple of years ago, I've been working with modular labs. Mm-hmm. So we understand the concern that this kind of labs, it's not easy to be built because you need to have the right expertise to build such labs, and you don't have the right material to build in a particular country as well. A remote place like I mentioned, Sierra Leone doesn't have the right material. You need to get the epoxy, and need to get the worker who understand how to apply the epoxy, make sure there are no holes in the floor. So we the solution to that is to use pre-built labs or modularly built lab. And this lab, there are big players like Germfree who builds lab in the US. So they are just built in container size labs, all pre-built, pre-tested, pre-commissioned, and they can just ship the lab to wherever you want. Hook up the power, hook up the water, and there you go. You have a running lab. The problem comes when it has to be maintained and certified, where you need to bring people in to do that, to supervise the installation work to make sure that it's running according to the needs. You can have backup gensets and all locally sourced. But yeah, the solution to such problem is to have it pre-built elsewhere to the required standards and guidelines, and then move that whole lab to wherever is needed. I mean, even Singapore did that a couple of years ago. They actually bought a lab from the US and moved the whole lab to Singapore. I mean, despite in a country where it's easy to build such labs, they have taken that direction to actually go to a reputable builder. It's all builded, tested, and then shipped to the location where you need the labs to be. But at the moment, they're also doing that with manufacturing plant. Back in many years ago, even in Malaysia, it's a facility called InnoBiologics. It's a vaccine manufacturing plant, which was actually built in France, and they shipped, if I'm not mistaken, about 11 or 12 containers, and then was just assembled on site, connected, and you've got a working plant. So that's basically the direction I would go to build a lab in an area where there's no capability.
That's great. Thank you. Well, let's just see in the chat. We have another question related to the previous biosafety cabinets question. Dr. Vips saying, is it easy to get biosafety cabinets certified in Asia, and are there companies enough for the need?
Yeah, there are many companies. I think there are also in this region between Singapore, Malaysia, and Indonesia. There are companies like ESCO that builds this kind of labs, a very common brand that we see. And typically they can source the certifiers to come and certify these labs, check all the components, and put in a sticker and give a certificate saying that it has complied. So basically the certification of the lab is not really a complex procedure. It's basically checking all the airflows, making sure there are no leaks, pressure testing the use. So they need to have the right tools. And yeah, they can be found. A lot of them are there in Singapore, Malaysia, Indonesia.
That's great. I have another question. I'm waiting to see if the participants will ask more questions on laboratory design, on biosafety and biosecurity. So my question is, there's a lot of good detail on your presentation about the control of air, liquid, and solid materials to make sure that nothing of biosecurity and biosafety concerns leaves the lab by normal routes. How would you recommend selecting employees so that they are sure they are reliable and they use the systems in place and don't intentionally misuse the information?
Very difficult question. I think a lot of that comes into the SOPs and operations of the lab. So as I mentioned earlier, like vetting of the people, right? So not everyone is allowed to enter such labs and have got access to this materials. So from my limited knowledge, a lot of that is a lot of the materials are really checked in volumes. Like if you have 10 vials of X, it has to be 10 vials stored in a particular password locked, fingerprint locked containers inside the lab. That is only certain people has got access to that. And if one of the vials gone missing, then you exactly know who has taken it. The second thing is a lot of these labs all comes with CCTV. The whole part of the lab is fully monitored by CCTV, and for that same purposes, we don't want someone to do something that is wrong. Actually, the main purpose of the CCTV is to also detect anomalies in the lab, like if let's say a beaker is broken or something like that. But the CCTV also helps to provides traceability if someone has taken something. So if the particular of course, we have seen in movies where people's eyes have been taken to use retina scans and open. I mean, they are movies, but in reality, if you have the right biometrics systems in place with proper surveillance, CCTV, and everyone that is employed in such labs are properly vetted, I think that will all minimize and mitigate such risk, but we cannot eliminate risk. I mean, like in every other thing, you cannot 100% eliminate the risk. You can have systems in place, SOPs in place, but the risk will always be present. I mean, like even in the air, you can have 2 HEPA filters, but if both the HEPA filters are torn, there's still chances of things happening. So we can only protect certain thing to a certain amount, not beyond the cost prohibitive.
Which actually brings me to another question, follow-up. So again, going back to the example that you gave about India, the project and the budget, and then the Singapore incident again. So if you were to work with an institution that doesn't have the budget to afford the biometrics or the cameras, so how would you advise them to address biosecurity, when the budget is limited? Again, when we're talking about biometrics, biosecurity, and cameras, what, in your opinion, would be the advice that you would give to a company or to a university laboratory?
My advice would be, if you don't have the budget, don't build such labs, because it's not about building such labs, because this lab needs a lot of money to operate as well. The operating cost of such lab can be very prohibitive, right? So if they don't already have money to implement simple things like CCTVs or even simple equipment that is mandatory for such labs based on the risk assessment, right? So we've done the risk assessment, we need 10 cameras, maybe we can live with 8. If another camera covers a particular angle, we can do that. But if to eliminate the whole CCTV is something that we will not do and we will not recommend, right? Because we cannot. These are critical functions of the lab, right? So HEPA filters. So for example, the HEPA filters needs to be checked and changed, after a few years or after a few months, depending on the load on it. One example I can give in Asia, we have on Malaysia, Singapore, Indonesia, we have the haze season, right? The haze where you have this, the air is really dirty. What happens during that time is all these HEPA filters gets easily clogged up. And if you don't have the money to change the HEPA filters, then the lab fails. You're not supposed to operate the lab. So these are some of the things which has to be really thought in, and the money has to be allocated for such incidences, right? So my advice is, if they don't have the money to meet the minimum compliance, don't proceed to build it, because the certifier will not certify the lab. If the certifier doesn't certify the lab, then the lab cannot operate at that designated grade. right? So that's why it's really important to bring the certifier or the risk assessment from the start of the project. They will evaluate the design, they will come and check during the construction, and they'll do all the necessary steps to make sure that the lab can meet its purpose. But if they say you don't have this, you don't have thumbprint control or no access control, for example, they will not certify the lab, right? So it defeats the purpose. You can build a lab, you cannot run it because it's not certified. So, yeah.
Right. Well, that's a very, very good answer. Yeah, thanks. I'm just looking again at the audience to see if there are any questions from the audience. No. So my other question to you is, you said you don't do risk assessment with the clients? Is that right?
The risk assessment will be done as a joint party, but we'll have someone who's driving the risk assessment. So normally we won't drive the risk assessment. We'll participate in the risk assessment process, give the necessary input as what is needed, but the risk assessment has to be driven by a consultant who basically lives and breathes biosafety. So typically we'll bring them on board. They will have all the challenge questions, and then the input on facility will be given by us, the input of the user. So sometimes we have also gone through this process in the past with some users. They said, I've got 10 agents that I want to work with. And then the risk assessment consultant will come and say, to work with all the 8 agents, you need BSL 3. But to work with these 2 agents, you need BSL 4. And then the user might say, okay, fine, I'm happy with this 10 agents. Then we can drop down. Right. So that's why you need that particular risk agent consultants to drive that whole process. We will not be able to advise, okay, you're going to use Ebola strain, what do you need PSL4 or not? It
Right.
doesn't go with
So
us.
have you had a chance to also discuss with the client, the mitigation measures or any evaluation methods of the mitigation measures that they need to take?
Yeah. So in terms of engineering systems,
yeah.
we will bring that to the table, and then we will present that, and then the consultant will say, okay, I think that might work. So you have, instead of installing, like what I said earlier about sprinklers, right? So instead of installing water sprinklers, we came up and said, okay, why don't you use gas suppression systems? Would that satisfy that requirement? And then we need to go to the fire safety system authorities and convince them that we have all this necessary precaution, and can you give us an approval? So when it comes to facility related, this is where we play our role in finding alternative solutions, but it has to be approved by the certifier or the consultants. We don't want to go against the consultant. I said, no, your system's not going to work, I'm going to propose this, and then we can build it, and if it comes and doesn't certify it, also defeats the purpose.
Right. Well, thank you. Thank you so much. We're almost close to the hour, and I just wanted to thank you so much for your presentation and the dialogue. And again, thank you everyone who contributed to the chat. I'd like to give the floor to Dr. Subhash or the moderator. I'm sorry, Dr. Subhash. Thank you so much, Joel.
Yeah, thank you, Iris. So I request MC Yinsing, please go ahead. Thank you.
Mr. Joel William, thank you very much for a wonderful talk. Thank you very much, Ms. Iris, for moderating the section. It was a great section today. On behalf of the organizing team, I'd like to thank everyone for attending our 10th program of the Biosafety and Biosecurity Month, October 2020. Before ending the section, we would like to hear feedback from all participants by scanning the QR code on the screen right now. We promise the evaluation survey will not take you more than 1 minute. Your feedback will be greatly appreciated. You can either scan the QR code or go to the link below. The link will be provided in the chat box as well. After completion of the survey, you will receive an instant participation certificate in a short while. And I will keep this live running for 2 more minutes for you all to scan the QR code. We're looking forward to have you all joining us on this Friday for the e-poster competition. Thank you again, everyone, and we wish you a good health and safety. I hope everyone have the chance to scan the QR code, and I'm going to end the meeting. See you soon in our e-poster competition. Stay safe and have a wonderful day.